The classical free electron theory successfully explained how the electrons can be behaved when it is under the influence of external electric field. And there are two cases we may consider. One is without external electric field and with external applied electric field. So see here, there is an atom here. So the center one is nucleus. Around the nucleus there are the particles like neutron, proton and electron. So here these electrons are situated at the outermost orbit of this particular atom model. So once you supply energy, these electrons may move. Because of the movement, there will be current. And here in classical free electron theory, there are two cases considered. One is without external electric field. See here, the electrons don't have any proper direction. So they are moving randomly here and there like molecules in a gas. But whereas here, once you supply some external electric field, these electrons will find a direction. That is this direction here in this diagram. The electron will find a direction which is opposite to the direction of the current. So this is minus and this is plus. This is the direction of the current. These electrons are moving opposite to the direction of the current. So because of this movement, current will be constituted. So this is what classical free electron theory explained along with the certain definitions. So one such definition is the drift velocity. So once you supply external electric field, the electron starts to move with a different velocity. So we have to consider the average velocity acquired by the free electrons. So that is what explained here under the definition of drift velocity. It is defined as the average velocity acquired by the free electrons of a metal in a particular direction by the application of external electric field. So since the electrons are moving with a different velocity, we have to take the average velocity. That average velocity is called drift velocity. And mean free path. So what is mean free path? So as I said before, there may be collision between electrons. So one electron may get collide with the adjacent neighborhood electrons. So the distance, the average distance traveled by an electron between two successive collisions. So we have to take two successive collisions and we have to calculate the amount of distance the electron have got. So there is average distance traveled by an electron between two successive collision is called mean free path. And similarly, there is another definition, that is collision time. So here in mean free path we discussed about the collision of electrons, and the collision time is defined as the average time taken by a free electron between two successive collision is known as collision time. So if it is average distance traveled, that is mean free path. If it is the average time taken by the free electron, that is called collision time. And another time is there, that is relaxation time. So what is relaxation time? So here, the average time taken by the free electron to reach its equilibrium position. So once you supply some external field, the electron may disturb. That means it may go somewhere. So what is the time taken for that electron to reach its original position, that is equilibrium position? So what is the time it took? That time is called relaxation time. The electron will be disturbed because of the application of the field. Once it disturbed, it will come back to the original position later. So what is the time taken for that? So it is the time taken by an electron to reach its equilibrium original position from the disturbed position is called collision time.